Hi, this is Margo. This is Monday afternoon, September 30th, 2019, and I hope everyone is doing well. I'm a little bit hoarse today, but I'm going to try and get through this report. I'm going to show sea ice in the Arctic and probably peek at the Antarctic as well. But before we do that, we're going to look at methane. So let's pull up our methane data from CAMS. I also have a report on the NOAA data that I'm tracking. They had data for this week. So here we have Copernicus Atmosphere Monitoring Services pulled up, showing methane. And I'm showing from Saturday the 28th. The latest data is from Sunday, and but the NOAA data is from Saturday, so this is so we can get a more accurate reading to compare. We're on the Arctic level and surface level for the reading. Here's the color chart down here that corresponds to all the different levels measured in parts per billion. We can see that the greens are in the 1900 to 2000 range. Once it gets into chartreuse and yellow, the yellow is 2000 to 2080 range, and once it gets to orange and red, it's pretty much 2100 and higher. And then this dark color, the darkest color, which is dark brown to me, sometimes I call it black, but the black is down here, 0. But this dark brown is anywhere between 2160 and 10,000 parts per billion. And someone left a comment under my show from last week saying that they were colorblind and asked if I could tell what the levels were since they were colorblind. So I don't know what it looks like to you when you're colorblind. I think reds and greens kind of go together, but so where it looks darker, that's where you've got more methane coming up. And like this, I don't know if the dark greens and the light greens all look the same. I don't know. So the best thing I can suggest is that you go over to Copernicus Atmosphere Monitoring Services, CAMS, and I always leave a link below to my research websites, and compare for yourself. Here's the chart down here. This is in parts per billion, and see what relates, what it looks like to you, because I don't know what it looks like through your eyes. So that's the best I can do on that. So I have the Arctic movie all pulled up and ready to go. So the data is from Saturday, and the forecast period runs Sunday through Wednesday. And their forecast period on methane is pretty accurate. Now what we've been seeing is pretty good sized release coming off of Iceland around the edges on the northwest, or from this position it's northwest and northeast. We're also seeing high releases still in the Scandinavian area and also in Siberia. And we're seeing the lighter colors of the green coming across the Arctic, meaning that's a higher level of methane release. We can see it as a wave coming all the way across. And this is coming up through the sea ice where it's trying to refreeze. It's having a hard time refreezing. Now also of note is right up here you see this big stream of methane. This is coming off the coast of Hokkaido, which is the northern island of Japan, and it's like this constant stream, and that's besides all this stuff coming up from China. So this is what the Arctic view looks like right now. And if we pull up the North Pole view, that gives us a view of the northern hemisphere. I've not loaded up this movie, but what we can see from Saturday is high releases in this Bengal Bay, or Bay of Bengal, and see this high release. This is surface level coming up out of the ocean, because the land mass is right around here. Myanmar and Tibet, not Myanmar, not Tibet, Thailand, Myanmar, and then comes on over into India, but see the edge of the land is like right along here. Here's Malaysia down here with Singapore. So I think, or maybe it's over here. It's kind of hard to see right in this view. But we have very high releases in the ocean, which is unusual, but it's cranking up over here in Asia. So there's the North Pole view. We also have the global view where you can see what's going on. We're seeing releases still in the Antarctic around the edges of the sea ice, or where the ice is coming up to the coastline of the mainland. We're seeing methane releases. So if we switch to total column, it's always worse than the week before, and to get the reading you have to refresh to get the correct color chart. Here the dark area is between 1920 to 2320 parts per billion. So here it is, total column as of Saturday. We can see that the red is moving on across, and anyway, it is, saturating through the layers and hanging on as it gets up higher. While we're here, I want to take a peek at ozone, because this is the end of the summer for the northern hemisphere and for the North Pole, and the beginning of spring. Okay, so we're in the fall now in the northern hemisphere. We're in the beginning of spring in the southern hemisphere, and there's the hole that you can see that goes all the way across, but it's also quite thin throughout the whole, most of the northern hemisphere. We're seeing in the chartreuse color, which is 260 to 280 Dobson units, And when we see the aqua, that's 220 to 240. Now 300 Dobson units is supposed to be average, but we can see most of the globe from even below the equator. The equator is about here, but even south of the equator we can see all the way up to the North Pole a lot of areas that are below average. So the ozone is thinning. We've got holes in the ozone layer, especially around the mid-latitudes here. But look at the Arctic, and this was disturbing to me when I saw this. We've got a big thin area right over Greenland. Oh, that's not loading. Okay, let's see if it'll load for today. Ozone is usually current. Here it is. This is the Arctic, and we can see that it's thin over the North Pole, and you would think that with it just coming out of summer, it wouldn't be thin, that we would have plenty of ozone up there. But no, we don't, and we've got a thinning right over Greenland, and this is an area, when we look at Climate Reanalyzer, that's in the brown in the 2-meter temperature anomaly, so it's warmer than normal. Also over here in the Finnish countries, or Scandinavian countries, and this is Russia right here. We've got another thinning. We've got thinning over here on the Tibetan Plateau. That is normal because it's so high up. But we've got thinning over here in Canada. We've got thinning across most of the United States and a lot of Canada. So, and the ozone protects us from solar radiation, UV rays, things like that. Let's look at the South Pole, and here's where the hole is right now. And it moves around if we load this up, and I don't want to take a long time loading it up. But we can see around it we have a lot of thick areas where it's much thicker, you know, reds and dark browns and stuff. But we can see that it's goes down into the 150 to 175 range. So that's still good size. And I know some people say, oh, the ozone hole is getting smaller, but it's healing. No, it's not, because it's just not. And look over here. We have areas where it's popping up. This black line is a demarcation between 220 and 200 Dobson units. So when you see the black line, you know when you're going under 220 Dobson units. Because we had thinning around the globe, not just at the poles, but it's around the globe, as I just showed you. So we're going to leave that. I might come back to this in a minute. I don't know. I'll just go ahead and leave that as a background. Now let's look at the NOAA data. This is from the METOP-1 and METOP-2 satellites from NOAA for the 477 millibar reading, but when you pull it up, it says 469 for the pressure, but it's 477 on the little GIF that you click on to get here. So they take 4 readings a day. Each satellite takes a reading in the morning and in the afternoon. So the METOP-1 satellite from Saturday in the morning, the mean was 1897, the range was 1486 to 2396 parts per billion, and this fuchsia range, that's the highest. You can see that scattered around in this whole northern hemisphere, also scattered around in the southern hemisphere too. Lots of high readings of methane. Look, even down here on the edge of the South Pole here, or the edge of the Antarctic. In the afternoon reading, the mean was 1896. The range was 1514 to 2361. Here's the METOP-2 AM, and these white areas are missing data. The mean is 1872, which is quite a bit higher than they normally have. The range was 1464 to 2370. And in the afternoon, the mean was 1874, and the range was 1479 to 2325. So I took those numbers and plugged them in to my spreadsheet over here, and I've been tracking this since March the 1st, and took all those numbers and added them up and divided them by 4, and so the mean for the 477 millibar level for the last week was 1884.75, and last week I did not do a report from the NOAA data because they were missing satellite data on METOP-2. So in 2 weeks it's gone up 4 parts per billion, and that's a huge increase, huge. And we can see, here it is on the chart, where it just hopped up from the 14th to the 28th. It hopped right up there, and normally we'll see it go up a little bit, go up, and then we'll see it go down. And it goes up and down, but the general trend since March the 1st has been up, and since March the 1st it's gone up 27.5 parts per billion. And just so people know, 477 millibars is at about 20,000 feet above the Earth's surface, or 6,096 meters. So there you have it. So methane is on the rise, definitely. Alright, now let's move on to our sea ice report. I prepared a slideshow for you. Get a sip of my tea. I'm getting hoarse. These are pictures that I've saved from Climate Reanalyzer. Here it is from today. This is the sea ice and snow cover. Here's what it looks like from today, the 30th. And so I'm going to click back through for the last week, and you can see how it's changed in the last week. There's the 29th, 28th, 27th, 26, 25, 24, and 23rd. So last Monday I did a show, and this is where the sea ice was at. So we'll click back through and you can see it's coming back a little bit around the edges. It's coming back through these tributaries in Canada. It's not real thick, but it's trying. It's struggling, but it's trying. Here's the navy image for the sea ice thickness from today, the 30th. We can blow this up. And we can see, here's the edge, and we can see it's quite thin around the edge, so it might not even be an inch thick. It might just be a little bit of frozen, or it might be pieces, not very solid. And we can see this hole that had been near the Arctic, near the North Pole. It's quite thin here. We can also see that it's thinned out. It was more solid along through here, but it's kind of chopped up. Here's the 30-day GIF. It goes back 3 weeks and forward 1 week in the forecast period. And even though we're seeing a little bit of extent, we're still seeing this very thin part to the right of the North Pole. And it's moving. I'm thinking the waves of the water, the ocean underneath is moving that sea ice and moving these patterns around. So we're seeing it mainly coming out a little bit. It's not getting that much thicker yet. It's trying. And then I made this movie for you. This is from NASA Worldview. This is from the 21st through the 28th. And this is sea ice concentration. The blue area is where it's less concentrated, and the white is where it's more concentrated. So even though technically we're at the end of the melt season, we could still see melting like we did last year. We saw it melting underneath, and we saw that it took a long time for the extent to come back and to refreeze because of the warm ocean temperatures around the sea ice. Okay, so that's what I had prepared for you on the slideshow. Now let's look at some websites. Let's hop over to Climate Reanalyzer and see what's going on today. Here's our maximum temperatures around the planet. We can see that the Arctic, it has some blues in there, which is showing 0 and below, and then here's Greenland, and this is where we had that ozone thinning. And we can see, if we look at the world view, these areas that are pretty hot, and even though we had snow up here in Montana and different places, and we had snow in Reno over the weekend. It melted, but that happened on Saturday, and it snowed up in the mountains. But we're having unusually hot temperatures throughout the Midwest and the South of the United States. South America's hot, Africa's hot, Australia's hot, and so on. Here's our 2-meter temperature anomaly. So here's where it's warmer than it normally would be. Even though we saw the blues, it's not as cold as it normally would be up here in this Arctic area. And then down here in North America, we've got cold, unusual temperatures that are lower than normal. And then here's this line that cuts right across, and then it's brown all the way across the United States. The northern hemisphere is plus 0.9 degrees Celsius. The Arctic is plus 2.5 degrees Celsius, warmer than normal. The world is 0.3 degrees Celsius warmer than normal. We also have a warming over here in China. And this part of Africa, and also in the Antarctic. Got some areas. Here's our precipitation map. We can see that it's raining and snowing over parts of the Arctic. Here we have another system coming across the Atlantic. I can't keep up with them. I try, and then it's like, okay, here comes another one, here comes another one. There are other people doing a good job of keeping up with all those systems. Here's your schizophrenic jet stream. Here's the sea ice and snow cover. Oh, there it goes. Here's your sea surface temperature anomaly. This is from Thursday. That's not up to date, but anyway, all around the edges of this Arctic sea ice is brown, and then parts are red. Also up here in the Baffin Bay by Greenland. Then over here in the Hudson Bay, it's warmer. And the Pacific is totally too warm. Look up here. Anyway, there's that. Next, we'll look at, this is the National Snow and Ice Data Center. This is from yesterday, sea ice concentration. We can see it correlates with the worldview data that I showed you. Here's the chart for the extent. Remember, extent is not concentration or thickness. And even, here's the blue line for this year, and even though it's not at the bottom, which is where 2012 was, it's lower than the other years, than these median years. And here's the Antarctic sea ice concentration for yesterday. It's melting fast down there. here's their chart, and the blue line is this year, and this darker line is from last year. So we're not as low as last year at this point. It's still low. Now, let's hop on over to NASA Worldview. There's from yesterday. Let's see if we've got that was from the 28th. Let's refresh and see how much data we've got. We've got almost all the data in, it looks like. This hole is from where the sun is going down. It's not shining at the North Pole. And this hole will get bigger and bigger and bigger until it covers everything up, and it'll go dark for months. So here's what it looks like today. You can see this is the edge of the sea ice. Look at these lines. The green, that's algae. So here's Greenland. We're looking through cloud cover here. There's no ice over here in the Baffin Bay. Looking through the clouds, you can barely see a little bit of the ice, but it's pretty cloudy. But right here, there are no clouds, and we can see there's just a tiny bit of cloud cover, but you can see the state of the ice here at northern Greenland. It's in very poor shape. It's very broken up, a lot of space between the ice and the coastline. And here it's refreezing back in these tributaries. Here's the edge of the sea ice here on this western side. That's what that looks like. Very broken up. This is the Beaufort Sea. Very cloudy. They've got rain and snow up there right now. Here's the Bering Strait. Here's Siberia. This is the East Siberia ice shelf underneath here, the Chukchi Sea. This is where that methane is stored that Natalia Shakova has talked about. Here's the edge. It looks really weird with the clouds today. It's almost hard to get oriented. Here's Novaya Zemlya, but lots and lots of weird looking clouds over the area. Here's the Yamal Peninsula. Here's the Kola Peninsula. This is Russia. This is Finland. Here's Norway, and here's Sweden. Here's Svalbard. Look at all those ripples. There's the edge of the ice trying to come back around Svalbard. Now the seed bank is right down here by Longyearbyen. Haven't heard anything about that. So that's what the Arctic looks like today. If we look at the Antarctic, now see their hole is almost gone because the sun is coming up down there. Down here, this is the Western Peninsula. Here's that A68 iceberg. Kind of hard to see there. Here's Pine Island Glacier. That's cloud covered. If we go back a couple of days, got a good view of the separation of the sea ice from the glacier. Normally that's all frozen together at this time of year because this is just, the sun is just now coming up. So the implication is it didn't freeze back in this area. That's the implication. I remember how this kept breaking off. It's been breaking off in the last few years and going in, and it's a huge amount of ice that's coming out. Here's more area that's ice free. You can see it. Now look down here. This is the Thwaites Glacier right here. That's another area that's in trouble. And this area here. Here's the Ross Ice Shelf. See what that looks like today. Now the Antarctic sea ice is totally different than the Arctic sea ice. The Arctic sea ice forms in the middle with the landmass around the edges of the ocean or of the sea. The Antarctic, the landmass is in the middle and the ice forms around the edges of the landmass. And so it normally melts every year. It doesn't get real thick. But the problem is this warm ocean temperature coming in and coming up under the edge of these ice shelves, and it's melting underneath. Look at that strange ice. Melting up underneath and causing the glaciers to calve. Things are calving off. Okay, I was going to show you the Brunt ice sheet. We were following that. That's where the research station was. And it's a little bit cloudy there. And they had to escape with a helicopter. They left all of their equipment when it started cracking across here and across here. So that's what it looks like right now, as best we can tell. This is on the edge of the Weddell Sea. This is the Weddell Sea, and this is the Weddell Ice Shelf. Here's the Western Peninsula. So the direction here, I didn't know this. I learned this after I started studying on how to read Antarctica. When you see this tail, that's the peninsula for the western side. So the directions are north. The Ross Sea is at the south. Over here on the east is this rounded part. This is also the Avery Ice Shelf over here, or ice sheet. That's melting too. And then the western side has the peninsula. The Larsen ice shelves are over here, A, B, and C. A and B have collapsed. C is in the midst of collapsing. Then D is down here. And Pine Island Glacier, and that area is right. And Thwaites Glaciers, they're right down here. And I've done some educational videos on the Antarctic about what's going on down there. It's on my YouTube channel, but it's pretty interesting. And there are over 100 volcanoes underneath the surface. A bunch of them are active, and they think that these active volcanoes are causing some of these glaciers to melt. And there's a whole landscape underneath, caverns and lakes, and it's a whole thing. It's really interesting. So I'll go ahead and sign off for now. If you haven't seen my video that I put up this morning called Why I Do What I Do, I recommend everyone go and listen to that. I just pulled the audio off of my last earthquake report, and I talked about why I'm doing this. I mean, I'm not doing this just to do this. I'm doing this for a reason, and I'm on a mission from God. I'm also showing earthquakes. Normally I don't show them in a sea ice update, but I just happened to click over here, and we just had, looks like a 4.0 at Snyder, Texas. Now that's like an oil drilling capital of the United States, and that's huge. I haven't seen a 4.0 there. Snyder, Texas is at the base of the Cap Rock, and the Cap Rock is an area in West Texas. I used to live in West Texas that's totally flat, and when you're coming up the Cap Rock, it's just hills up and down, up and down. It's like canyons, and Snyder is at the base of the Cap Rock before you start coming up the hills. Lubbock is on the top of the Cap Rock. But yeah, that just came in 4.0, 5 kilometers deep. I'm absolutely certain that's from the drilling operations. I also wanted to show you real quick over here in the New Madrid area. They've got, I would say it's an event going on. They've got 6 earthquakes in the last 24 hours at Lilburn, Missouri, which is part of the New Madrid hazard area. The highest one, or the largest one, was a 2.7. So they've had 2 2.7s and 2.5 and a 2.6. So that's, normally we don't see that many there or that big there. Also, we've got, what's going on down here? 8 at Beatty, Nevada. That's not unusual. We had an event going on at Mammoth Lakes. Last week there were like 100 here in one day. So that's kind of gone back down. There's only 14 in the last 24 hours. But also of note, over here in the Livermore area, there's, I would call it an event. By Dublin, there have been 7 earthquakes in the last 24 hours. This is near Livermore. There's Livermore Laboratory, which is a top secret area. They've got a collider, a hadron collider there. And now here are these earthquakes next to it. In the last 24 hours, 7 there. Then here's 2 more, a 1.5 and a 2.3 near Oakland. Now the Hayward Fault comes down here, so that would probably be on that Hayward Fault. We've got some larger ones coming down beside the San Andreas Fault line, a 2.2 Morgan Hill, 2.0, 2.8 Tres Pinos, 2.2 Tres Pinos, 2.8 San Simon. So we can see these are getting bigger. They're getting larger in magnitude from what I was reporting. I was reporting every day, but I got too busy. I was taking care of my friend. Here's one on the Fulcrum Point, a 2.5 at Petrolia. So, but when I was doing the daily reporting, we weren't having these big ones. They were like 1s and maybe a 2, but we still are having earthquakes in this Ridgecrest and Searles Valley event area. We've got 85 here in the last 24 hours. 2.3 there. So this has not stopped. It's slowed down. It's not 400, but it's still 85 in a day. I would say that's an event. I would say. Look, this one just came in near Las Vegas, a 2.4. So we're in the end days, and I'm documenting this stuff and reporting on it to try and help people understand where we are in this timeline of events. And we're seeing earthquakes in diverse places for sure. Look, here's one right in the cone of Mount Rainier, a 1.5. That's an old volcano. Here's one near Seattle, 1.8. Here's 2 near Titan, 2.0, 1.3, and so on. Then we're seeing things up here in the little armpit where this red line comes up. This is where the Pacific plate meets the North American plate. So we do see activity, 3.5 there, 2.7 there. We're still seeing activity up here in the Arctic Village area. Here's a 3.2. 5.6, and then they had that big, what's it, a 7 something that came in yesterday here at Constitucion, Chile. These are aftershocks. I think they downsized it to, can't remember. Let's go. Here it is. 6.8. They downsized it to a 6.8. That was yesterday. So these are the earthquakes that have happened in the last 7 days. 4.5 magnitude or higher, 105. 4.5 and higher. So that's a huge number. Look at these up here in Russia. There's a 5.1 and a 4.6. Then a 5.0. This was in the ocean just off the coast of Russia, between Russia and Hokkaido, Japan. Now the orange color means it's happened in the last 24 hours. Here's a 4.7 in the Kuril Islands. See all these by Japan. So things are rocking, you know, they're definitely rocking. So that's my show for today. I'm praying for everyone, and my message is time is short. I recommend you get your spiritual house in order. If you haven't done so already, get right with God and Jesus, because in these end days, that's going to be our only protection against the satanic dark forces. So I love you guys, and until next time, God bless you. Go in peace, and goodbye. Oh, and if you like my work and would like to support my work and follow all of my postings, I recommend you go over to my Subscribestar page and check that out. Okay. God bless you. Go in peace, and goodbye.